Introduction, Materials, and Procedure. Students activate a hopper by flipping it inside out and then setting it on a flat surface for a launch. And when you see the video, hopefully that'll make a little more sense to you. It's hard to describe in words. Using a meter stick, students will measure the maximum height reached by a large hopper and a small hopper. They'll use these data to find the time of each hopper in the air and then their initial velocities using the kinematics equations and the acceleration due to gravity. Here's what we'll be using. Very low material lab here, low budget lab here. One large hopper, one small hopper, and a meter stick for each lab group. So here's the basic setup. We'll invert the hopper, and you have two different hoppers, place it on a table. The hopper will then launch to a maximum height that can be measured with a meter stick. So the student should look at it, and when it starts coming down, that's the height. And what might be helpful here is the students can use their phones maybe, put them in slow motion, and they can get a more exact height then. They'll record 5 heights for each hopper, and then find the average height for each. The height and the gravitational acceleration constant, g equals 9.8 meters per second squared, are then used to determine the time in the air. It's one thing that we'll find, and then the initial velocity. Minimal preparation is required. Just be sure that each group of students has a large hopper, a small hopper, as well as a meter stick. If you can't get hoppers, you can get various suction cup spring-loaded novelty toys, and here's a picture of them. Just make sure that the toy can go at least 20 centimeters in the air, or 0.2 meters, so that students can make measurements on the maximum height. Here's the student procedure, and they can actually have a copy of this. 1. Invert the hopper, place it on your laptop or lab bench. Using a meter stick, determine the maximum height the hopper reaches after you let it go. Repeat the process 5 times for each of the 2 hoppers, so that's a total of 10 runs. And then fill in the chart with your data, and we'll give you the chart here shortly. Couple minor warnings for this lab. The hopper should be fully inverted and launched from a stable hard surface. Please don't have the students position their head directly over the hopper. We don't want it hitting any of them in the eyes, so they should be looking at it from the side. And they could also wear goggles too. That would be a good idea. Safety glasses. Note that after many uses, the hoppers can become cracked in the center, won't hop up very well, so they should be replaced with new hoppers. Here's a data table that the students can use. After completing at least 5 trials, the height data can be averaged for each hopper. Here's the key thing. Even though they may be measuring in centimeters, fill in the chart with meters. And why? Well, one reason, g is given in meters per second squared, so all units have to match. So let's start with the large hopper. They do 1 trial, 2 trials, 3, 2 more, and then you would average these 5 together to fill out the average height, then do the same thing for the small hopper. As mentioned earlier, you may not understand what it means to invert the hopper and place it on a table, so go ahead, please, and click on this, and it'll give you a video demonstration of it.